Um, Welcome to our presentation on industrial engineering. We hope that this is helpful in a time that's a little bit confusing, definitely, but we'll try and kind of walk you through our experience with the program and kind of what you have to expect in the coming years. To get things started, this building right here is Freeman Hall, and it's where the majority of our classes are located. At Clemson, you start taking industrial engineering classes your sophomore year. So you would end up taking classes in this building your second year, not necessarily your freshman year. If you want to get to know more information than what's on these slides, definitely go check out our Instagram. I think it's just Clemson Industrial Engineering. The Facebook page is, I think, Clemson University Industrial Engineering, but there's definitely great information on there that you can go look at as well. But we're going to go ahead and introduce ourselves. My name is Mallory. I am a senior in the department from Rock Hill, South Carolina. That's actually where I am right now. As far as what I was involved in undergrad, I was also a university tour guide, so I gave tours of the entire university as well. I was involved in Alpha Pi Mu, which is our department's honors fraternity, so it's just kind of like you hit a certain GPA and you get involved in this club and make great connections. Additionally, I was in the technical sales club, which kind of provided me opportunities in that field. As far as my work experience goes, I was a girls camp director at a camp that I actually grew up at a few summers ago. And then this past summer, I was a technical sales intern at Train down in Columbia, South Carolina. And then looking towards the future, I'm actually attending law school in the fall. So definitely kind of a strange path, but something that I've always been passionate about, and I'm excited to kind of meld my undergrad with law school and see how that goes.
All right, y'all. So I'm Abby. I am from Charleston, South Carolina. My involvement in the department was as the president of the Society of Manufacturing Engineers. I was also in IISE, which is basically just Industrial Engineering Club. That's something that most people in the major get involved in. I did several creative inquiries with different engineering departments and with Engineers Without Borders. So a creative inquiry is undergraduate research. You work with a professor or a faculty member on a project that they are doing research on, and you get to help them and get class credit for it. And my work experience has all been at a company called Eaton. So I interned there for 2 summers. One summer I was a continuous improvement intern working on heavy-duty truck transmissions. And the next summer I was a quality engineer for hydraulic pumps for airplanes. And I will be going into their leadership development program in July.
Hi, y'all. My name's Hollis. I'm a junior from Sutton, West Virginia. I'm also involved in a lot of stuff. I'm in a sorority that's called Sigma Kappa, and then I also do some intramurals. I'm in a creative inquiry, which I'll talk about a little bit more in a second. And then I'm part of the Honors College in the Society of Women's Engineers. I'm also a chairwoman for the regional conference planning for IISE as well. And I participated in the Accenture Innovation Challenge this last year. As for work experience, I'll go ahead and start with my creative inquiry, which is basically my undergraduate research. I'm working at a off-campus facility, redesigning the facility layout for a bunch of Society of Automotive Engineers, like Formula One and Baja cars. So that's really cool, and that's done through Clemson undergraduate programs. And then my first year after college, I was a process improvement intern at the Thrasher Group back in West Virginia. This last summer, Cam and I headed to Germany, and we were wind energy research interns for a summer. And then this next summer, I'm planning on going and working for the same company as Abby as an intern. So I'm going to be working at Eaton as an operations intern this summer.
Hey guys, I'm Cameron. I'm a junior from Greenville, South Carolina. Some things that I've been involved in undergraduate are intramural basketball. I like to play sports a lot. Creative inquiries such as a leadership development inquiry called Lead Forward. And this is a little bit different than your standard engineering creative inquiry, which shows that Clemson has a lot of opportunities for you to spread out and kind of get the feel of what you like and what you don't. I'm also involved with the National Society of Black Engineers, as well as some work experience that I have. I've been a co-op for 2 terms so far, and hopefully I have a 3rd this summer. I've been a process improvement co-op at Shaw Industries in Dalton, Georgia, as well as a process engineering co-op with Shaw in Cartersville. I also did the wind energy research internship in Saarbrücken, Germany with Hollis. That's a really fun opportunity and something that the Clemson IE program hopefully will keep doing in the future.
Hey guys, my name's Whit. I'm a senior from Beaufort, South Carolina. Some of my undergraduate involvement is I am currently the president of the Clemson Consulting Club, about to pass that on. I'm also involved in Alpha Lambda Delta Honor Society, which is just one of the many honor societies on campus. I've also participated in on-campus consulting projects with some of our professors. And like Hollis said earlier, I also worked on creative inquiries with some professors. Some of my work experience, I put a dock hand on there because that was my high school and early college job, and it doesn't really seem like it would relate to industrial engineering, which is why I include it, because industrial engineering relates to a lot of fields that you wouldn't typically expect. The next thing I did is I took a manufacturing engineering co-op position at a place called RBC Aerostructures, which makes specialty parts for airplanes for companies such as Lockheed Martin and Boeing. After that, I went and got an internship with Accenture, which is a large consulting firm in Washington, D.C. And I helped a financial client work on a cloud migration. And then I ended up accepting a full-time offer with them. And I'll be going to Atlanta, working in their technology development program as a technical platform analyst.
So I know a question we get a lot is, what is industrial engineering? I'm sure that's why you're probably watching this video right now. And for all of us, we were fortunate enough to kind of just like be a part of the department and figure that out. But a lot of people don't know what it is because it is a relatively new engineering discipline. I think it was formalized in like the 1960s or something like that. But put simply, it's just making people, products, and processes better. So improving them in some way. So whether that's improving them to be more profitable or to be safer or to be more efficient, whatever it is, you're just improving them to be better. And you can see that design and implement systems and processes that improve organized effort. So that's really what our effort lies in. And it's definitely something that encompasses many different industries. There's a lot of people and a lot of processes and a lot of products out there that we're able to work with. And our degree kind of gives us the background to be able to do that. So there are 5 main areas of industrial engineering, and we're going to go through and talk about each of these. And these are just kind of common areas that people will go into after graduation. It's not like an emphasis that you have to choose or anything like that. It's just what people tend to lean towards. However, they're not mutually exclusive, so you could totally, be doing manufacturing, but also have your toes dipped in like supply chain or whatever it is. So they're not mutually exclusive. You can absolutely be doing multiple or do none of them. It's really up to you and what your interest lies in.
One area that I've had a lot of experience in, or I've interned in so far, is the manufacturing and service systems role. I was a process engineer, like I said earlier, intern. And in this role, you'll see a lot of manufacturing where you'll have about you'll have a majority of your industrial engineers go into this setting after college, where we have anywhere ranging from process engineers in production to in a plant, you can have quality engineers as well. There's a lot of roles for industrial engineers within the manufacturing setting. For example, this picture in the bottom left corner is a BMW plant in Spartanburg. And this is a process where they're trying to check for defects in the automobile frames. And this could be an industrial engineer's job through process engineering. And how can we make this process more efficient? How can we check the frames quicker, things like that. So basically just getting as many parts out with as little deviation as possible. And the picture on the right is a line at an airport where we would have an industrial engineer come in, and he needs to determine how can we get this line to go by this much faster. In a way that we've learned that would be efficient, or a good way to do that would be to develop a queuing model or something like that. And, this is just optimizing and making processes go faster so that we can produce more or decrease variation.
So the next bucket is supply chain and logistics. So supply chain is all about getting things from point A to point B the most efficient as possible, optimize the process, reduce the cost, basically make it as perfect as humanly possible, or anyway. So if you imagine one of these warehouses that you see in the picture on the right, you have to think about what goes into making sure that those boxes get from production to storage. And then from storage, there has to be an industrial engineer that programs a machine to go and pick up that pallet, bring it to the next location, and mark down where it needs to be going. So if we think about Amazon's supply chain, they have to get it from their warehouses to your front door in 2 days with Amazon Prime shipping. So they have to really be on top of their game, know where everything is, have everything super organized, and make it go from point A to point B as fast and as cost effectively as possible. We don't want to lose any money. It also is inventory management. So it's making sure that whenever you need another piece, you need like more screws for a product that you're making. You need to make sure that you're going ahead and ordering the new batch before you run out of the old batch, so that you're not in a period of time where you're not getting any work done. Risk management, so making everything safer, up to OSHA standards, making it even more so if possible, making it a good work environment to work in. And then there's a lot of other smaller things that fit inside of that, but it's really just optimizing a process from point A to point B.
So operations research is kind of the mathier side of industrial engineering. So we take a lot of classes in probability and statistics and how they can relate to engineering. And we use that math, that same logic and reasoning, and apply it to a factory setting. So for example, you see those boxes up there. We're going to use the same math and logic that we use in this weather forecast in there. So what I mean by that is, given that it was sunny yesterday and it rained 3 days before that, what's the probability that it's going to be overcast tomorrow? And you're just applying that same thing to a factory setting. So you're saying, given that we need 40 products produced by Monday, how many people do we need working the night shift? How many people do we need working the day shift? And you're really using that to plan like human resources, how many people you want working, or just like physical resources, how many raw materials you're going to need to have in the factory. And you're using a lot of models in order to forecast that and basically make a really good guess of what you're going to need in order to save your company money and produce enough products for your customers. And so you do a lot of statistical analysis and routing optimization with that. And so you're simulating randomness is really what you're doing. You're just taking your best guess using educated mathematical models to make that. The reason why we have a picture of like a colorful Excel looking chart up here, that actually is an NFL master schedule, from a few years ago. And you use that same kind of forecasting and same kind of thought process in order to schedule your football team's games. So for example, the Panthers have 12 industrial engineers on their staff. And some of them are doing other things, but one of them is designated to make the schedule. And they look and they say, all right, so we're going out to the West Coast next week. And then we're going to come back to the East Coast. We don't want to go back to the West Coast 2 weeks from now. That's a lot of traveling, not a lot of downtime, time for injury recovery and things like that. So you're going to want to optimally route where your players are going and when they're going. And it's also kind of cool in the fact that you wouldn't think that a sports team would hire industrial engineers, but they do. And that same can be said for multiple different industries. So really, if there's something you're passionate about, there's probably a way to mix what we learned in undergrad with whatever you're passionate about.
Okay, so quality is another one that uses a lot of math. As you can see in the top right, there's a chart with a lot of different kind of distributions and plots going on. So basically a quality engineer's job is to make sure that the product that a customer is getting is what they wanted. So if you were to go to the grocery store and pick up a pint of Ben & Jerry's cookie dough ice cream, and you took your first several spoonfuls and there was no cookie dough in it, you'd probably be pretty disappointed. So that's like one example, but it can apply to really any product that's being produced. You want to make sure that the process is in control, and if it's not, you want to learn how to make it be in control. So we take several different classes that show us how to do this, but also we have a technical elective class on Lean Six Sigma that if you take it and complete it, you end up getting your Six Sigma green belt. So your green belt is something that companies really look for because companies would love to achieve Six Sigma. And if you have your green belt, and it means that you understand the processes, you understand what you need to do to achieve Six Sigma. So that is something that makes you more attractive to them. They want to hire you. They're likely to give you a higher salary coming out of college just for having that. And it's a class that you pretty much need to take anyway. Like I said, it's a technical elective. So within our curriculum, we have to take 3, and this class is offered every semester. So basically, you can go ahead and take it and kill 2 birds with 1 stone and raise your salary in the process.
So human factors is kind of where industrial engineering meets people. And I like to think of it as containing 2 broad domains. So the first one is physical things such as like ergonomics, and then the other one is psychological. So with the ergonomics, you're looking at, a lot at like manufacturing plants and what type of physical stress the worker is going through and how you can improve their work environment to avoid like work-related disorders and things like that. The psychological side is used more to assess the limits of people and to really understand why they do what they do. You can see on the screen that there's an airplane cockpit, and human factors actually started in World War II because the airplane cockpits were so poorly designed. And so there were a lot of crashes, and they had to find out a way to stop all the crashes. So you can see all the controls in the cockpit, and really only the pilot has to use like a small portion of them. So a human factor engineer's job is to go in and kind of look at what's important to the pilot and what they can do to design that control to where the pilot's gonna not make any mistakes when he has to use it, and also notice a display or something when he has to recognize it.
So I think we all touched on this a little bit, but we like to say that the world is really our lab. What we mean by that is that you can really work anywhere in any industry in any capacity that you want to. And you know, industrial engineering can be as technical as you want it to be. You can be on the manufacturing floor, working next to everybody with the tools and the equipment and really designing first-rate products if that's what you want to do. Or if you want to be in an operating room, there's a place for you in an operating room as an industrial engineer. So we really like to say that you aren't stuck necessarily in a lab. I think a lot of engineers get stuck with that stereotype. You can be in the CEO's office of a business, you know, whatever it is, wherever you want to go, you can do it. And I think that's one of all of our favorite parts about the department is just the our ability to kind of launch from here to wherever we want to go and do whatever we want to do. We're pretty fortunate in that regard, and it helps that our whole curriculum is based on just solving real world problems and really critical thinking, because that's going to be valuable no matter where we go.
So our department recently was ranked in the top 15 among public IE programs, so that's a huge achievement. We have a new department chair actually this year, and the top 10 is definitely in his sights. Right now we have 571 undergraduates, and that number has actually doubled since Mallory Witt and I came in our freshman year. That just kind of shows how much of a demand there is for industrial engineers, how much the department's growing. And we also have graduate programs. You can get a master's in engineering, science, or a PhD. And with our master's program, we have a BS to MS offering. So you can not have to take the GRE, start taking master's classes your senior year. And in 5 years, you can graduate with both your bachelor's and your master's degree. So that is something really great that Clemson offers. Currently, this semester, we have 17 teaching faculty members, but they've hired 5 more to come on in the fall, and they're still working on hiring each semester to meet the growing demand of students.
So these are just a couple of clubs within the department. So you can see in the top left, Alpha Pi Mu, and in the middle, Institute of Industrial and Systems Engineers. So these are kind of the 2 main clubs in the industrial engineering department that pretty much every student gets invited to join. Other than that, you see that there are clubs where you can kind of dive a little bit deeper in with your interests. So like the Human Factors and Ergonomics Society, if you're interested in human factors, or SME if you're interested in manufacturing, or Institute for Healthcare Improvement if you're interested in healthcare administration or something like that. Also, as we mentioned earlier, there are the creative inquiries where you can actually work on real world projects where you're kind of guided by professors. And that's a really good way to get work experience before you get that first internship or co-op.
So sophomore design is pretty unique to Clemson University. I don't personally know of any other schools that do it. So you might have heard of a capstone project or a senior design class. Well, this is the sophomore version of that. So sophomore year is about the first year that you are taking actual industrial engineering classes. You've just gotten out of your gen eds. You don't really know anyone in the department. So they put you in this room with all the other sophomore industrial engineers and put you at big tables, and you get with a team, and then you have to collaborate and work on a project that's either on campus or a product that you're redesigning. So my group did the lines at the campus Chick-fil-A. Someone made a laundry basket. Really, the options are up to you, but the class goes well to teach you the basics of industrial engineering, what it would be like to be a process or product engineer. And it's really great because you get to start knowing the people that are going to be taking classes with you until you graduate. So it's really the first time you meet friends in your major, and it's the first like real taste of like the industrial engineering and what you can expect from our major. And then in addition, it's really nice because this gives you a push over everyone else that's applying for internships after your sophomore year. You kind of have some work experience, you have some team experience, and so this gives you something to talk about in interviews or put on your resume, and then you can have a little bit of knowledge at least that can put you a step up over everyone else. The reason that we have our basketball coliseum, Middlejohn, up here is because a couple years back, the university asked the sophomore design industrial engineering class to go and reimagine the concession stands in this facility. And so those concession stands and the sophomore design classes ideas for them are still in use today. So it's just a cool way you can see how, as a sophomore, it left a lasting mark on our university.
Next, we have our internships and co-ops. Where at Clemson, our co-op program is actually really nice, where we have, for the industrial engineers, we have an advisor where they'll take you through the entire process of getting a co-op, where they'll set up what companies you're going to interview with, how many companies you're going to interview with. You get to know a little bit of information beforehand about some of the companies. Then they have an interview day where you interview, or an interview week where you interview with a ton of companies throughout the week. And it's really nice to have that person there to walk you through the process of that. And co-ops tend to stick with their rotations, and they kind of know where they want to go with that, whereas internships are kind of just touching bases and feeling where you really want to go with industrial engineering or anything like that. Our internships just tend to be something where we're not really sure which kind of department we want to go into. So maybe we want to go into a quality role. So we might go to a certain company, or maybe we want to go more into an operations research role where we'll go to a different company. And it's just really nice that Clemson has those opportunities through our Career Center. And some companies that Clemson students co-op or internship with are BMW, UPS, Bosch, Michelin, and a lot more.
Okay, so senior design is kind of like sophomore design on steroids. It's an opportunity to use everything that you've learned in all of your industrial engineering classes, everything that you've learned in your internships and co-ops, and kind of put it all together to work in a team of 4 or 5 people in your major to solve a problem that a company has. So as you can see by the examples on the screen here, these are really big companies that have problems they're facing, but they may not really have the time or the resources to get their own employees to handle it. So they come to our department and they say, hey, this is what's going on. Can your student help us with it? And if our professors think that it's a project that would be a good use of our time and something that we could take on, they're like, yeah, sure. And they give it to us during our last semester. So it's a really great opportunity to kind of make sure that you do understand everything. You're putting those tools to work. It's a good opportunity to develop your soft skills. So you're working a lot with people who are actually in the industry. And it's kind of getting your foot in the door. So if for some reason at this point you don't have a job yet, you have a great connection with a pretty big company. And likely at the end of it, they are going to offer you and the rest of your team a job, whether you have one or not. And if you don't have one, at that point you could accept it and problem solved.
So these are kind of what we call the honeycombs of the curriculum. And basically what this means is we take classes in all of these honeycombs, and we touch and learn about all of them, and they're all included on the Fundamentals of Engineering exam. We shorten that to FE. The reason why you would take the FE exam is so that one day you qualify to take the PE exam, which is Professional Engineer. When you're a professional engineer, you're able to sign off on documents and drawings and things like that, and it can sometimes be valuable to your career. As an industrial engineer, it isn't really the standard to take the FE or the PE. We just don't need those designations in order to work in our industry. They're not really necessary. You aren't like limited in your job scope. You're able to go as high as you want without it. But you're absolutely prepared to take it. I will not be taking it. Abby and Whit, I don't think are taking it. I think we have maybe one friend who is. So it's definitely not the norm, but if you want to, you absolutely can.
So let's talk numbers, because I know that's what everyone likes to hear. So the average starting salary for an IE graduate is about $70,000, a little bit less, but the median salary is about $87,000. So it's really, it only goes up from there. The median mid-career salary is $166,000, which is the second among all U.S. occupations. It's growing in the last few years, so this is a little bit outdated, just by a year or so for some of them, but it just really shows that we're pretty valued. And I'd like to mention that this is just for industrial engineers, like with that title in their name. So this doesn't include people who might branch out into a managerial role or climb through the ranks so that they're not really an industrial engineer anymore. This is just the people with the job title of industrial engineer. So it really just depends on what field you go into and what job title you end up with. So obviously this is since 2010. The industrial engineering employment opportunities are up by 14% and they're growing. So it's going to be about 8% per year for the next 10 years or so, and shows no sign of stopping. Like we said, the world is our lab. People are starting to realize how much we can be used in just about every field. Football teams can employ us. We can be employed in hospitals. There's really no limit on where we can use our degree and what field we can go into. So most companies are now employing industrial engineers because everyone needs a little bit more optimization in their processes and products.
So these are kind of two of our head honchos. Dr. Nyans is an associate professor and the undergraduate coordinator. Abby Mallory and I, at least, have all had a class with him. He's a great professor. He also, all of the students are required to have career advisors along with some other advisors, and he's my career advisor. It's really nice to kind of sit down and talk to someone who knows about the industries and things like that, and just talk through it with them if you're unsure. Dr. Karufi is our new department chair. I've gotten to know him pretty well over the past year. As Abby mentioned, he's got the top 10 in his sights for top IE programs in the country, and I have nothing but confidence that he's going to do it. If you come into this program, you're coming in at a great time. Nothing but good things to say about these two.
So Sarah is our undergraduate coordinator, and Mo's the graduate coordinator. Essentially, they're like our guidance counselors, I guess that would be a good comparison. They help you with your registration when you're trying to decide what classes to take, and they're going to make sure that you're on track to graduate in 4 years or 5 years or whatever it is your goal is, and make sure that you're not taking 22 credit hours your last semester as a senior. So great people, really friendly and super open to questions and things like that. So feel free to Google them and reach out to them if you have any questions. But that's it for our presentation. We hope that this helped you guys in your decision and learning a little bit more. You're definitely already ahead of the game if you're learning about all the different engineering disciplines. And we would be glad to be resources for you. We put our emails on our slides, so feel free to reach out. We can definitely answer any questions you might have, but we hope that everybody stays safe and washes their hands and enjoys this time with their families. So thanks, guys.